Okay, so today, mostly what I want to talk about is factoring what we call perfect cubes, either a cube plus a cube or a perfect cube minus a perfect cube. And when I go through the notes, you're going to see how this works, okay? But if you've got a cube plus a cube, it factors into an a plus b, a squared minus an ab plus b squared. If it's a cube minus a cube, the only difference is the signs are reversed around a little bit. So it's an a minus b times an a squared plus an ab plus a b squared, okay? So I always remember it's plus minus plus and minus plus plus, right? If you don't memorize it, you don't have to memorize it because we'll have it on the board, okay? Let's find out where this is used, all right? So let's take a look, and we'll get to those when we get to the back side of the page. But for right now, let's go back through factoring, because this is what we want to talk about today, is factoring polynomials, all right? So let's do example 1. So first of all, example 1 says multiply. So if I'm going to multiply, I'm going to go this times this, x cubed, this times this, minus a 2x squared, this times this, minus an 8x, right? And then I multiply that times that, which makes a negative 3x squared, this times this, which makes a positive 6x, and this times this, which makes a positive 24, okay? And I like to do it this way because I've got things lined up, right? We've done this before, right, Garrett? We've done this before, and I like to do it so things are lined up so it makes it easy to add. So I just bring down the x cubed minus my 5x squared minus my 2x plus 24, okay? So that's my polynomial. That's another way to have my polynomial. So p of x we can say is equal to, well, that's our x cubed minus 5x squared minus 2x plus 24. Okay, that's a polynomial all multiplied out, okay? Now, divide p of x by x minus 3, okay? And we want to find the remainder, okay? So let's go ahead and just use synthetic division, right? That's the easiest way to do it. So we do synthetic division. We'll take our opposite of that. We'll put a 3, right? We'll put our upside down division sign. We want to divide p of x, which is that one there, 1, negative 5, negative 2, and 24, and see what we get. Step 1, bring down the 1. 1 times 3 is 3. Now I'm going to add, I'm going to get a negative 2, and then I multiply, negative 6. I'm going to add negative 8. I'm going to multiply, negative 24. Is it a factor?
Yeah.
Yes. Remainder is 0, so it is a factor. So we know that x minus 3 is a factor, okay? Now, so p of 3, I don't even need to do it. I already know the answer, right? If I go p of 3,
0.
Yeah, I know that. I could do it. I could plug it in, but I already know it's going to be 0 because of the remainder theorem, right? So that's done. But now what about p of 4? Well, I might have to plug that in to find out what p of 4 is. So I'll actually do that. I'm going to go p of 4 is equal to, well, that's my 4 cubed minus my 5 times my 4 squared minus my 2 times my 4 plus 24. And I'm going to use my calculator just because, you know, I don't want to do that in my head. I could, but why not just use a calculator, right? So we'll go 4 to the third, subtract 5, 4 squared minus 2 times 4 plus 24, and I get 0. I get 0. So if p of 4 is equal to 0, that means that x minus 4 is a factor. You okay with the x minus 4? By writing as x minus 4, we would get the 4, right? So x minus 4 is a factor. Is a factor, okay? Now, let's try p of negative 2. All right, so p of negative 2, I'll squeeze in here. So p of negative 2, let's see, that should be a, well, we'll plug it in. We'll have a negative 2 cubed minus 4 times negative 2 squared minus 2 times negative 2 plus 24. And I'm going to put that on my calculator, same thing, because I don't want to do all that work.
Minus 5, not minus 4.
Oh, I would have made a mistake.
Did you write it right?
Did I get it right?
No, you didn't. Yeah, you
I'm
just
good.
said negative 4.
Oh, thank you, Micaiah. I always need all the help I can get. You guys agree with that? I make mistakes all the time. I'm admitting that on camera, aren't I? Subtract 2 times negative 2 plus 24. I get 0 again. So that means that,
Plus 2.
yeah, x plus 2 is a factor. So let me think about this. If I had a number like 30, just a number, just a little side work, we'll do a little side work over here. If I had the number 30, its factors are 2 times 5 times 3, or in order 2 times 3 times 5, right? So if it's a factor, you can write it in factored form as 2 times 3 times 5, because that makes 30, right? You guys agree with that? Well, we can do the same thing. That means that this polynomial, way up here, this polynomial could have been factored. It could have been factored into, you ready? Could have been factored into a x plus 3, or I'm sorry, x minus 3, there's my first factor, times my x minus 4, that's my second factor, times my x plus 2. And that's what the whole idea of being a factor is. If all three of these numbers were factors, that means it came from these equations. That means this times this times this would have to be our original polynomial, because they're factors, right? And if you want to take the time, which I won't, if you want to take the time, multiply it all out, you will get x cubed minus 5x squared minus 2x plus 4, because these have to be these are all their three factors, right? And it has only 3 because of the x cubed. X, there's my x cubed, okay? Okay, so it just shows us something that we know. Now, let's take example 3. Is 1 a factor? I don't know. Let's try it. Okay, let's try it. Let's go f of 1, so we'll go to 1 squared plus a 2 times a 1 minus a 3. You get 3 minus 3 equals 0. So yes, 1 is a factor, which means that x minus 1 is a factor, right?
Couldn't you just also just
You need to teach, because you just took my exactly what I was going to say. I like that. So Becca's thing, why do we have to do this? We won't just factor, right? You guys agree? So this surely would be the hard way to factor things. If we know how to factor, let's just factor. In fact, hey, example 4, let's factor it. What does that factor into?
x minus 1 x plus 3?
X minus 1 and an x plus 3. Yeah. Awesome. We already knew x minus 1 was a factor, but we can factor it and get a lot faster. You guys agree? Yeah. Example 5. Let's just factor it, right? So if I factor example 5,
3 minus 3.
yeah, x plus 3, x minus 3. And if you plugged in 3, you'd get it a 0. And if you plugged in negative 3, you'd get a 0, right? You can just see that one, okay? Easy. Okay, example 6. What are we going to factor that into?
X squared.
Yep, x squared.
3 and 3.
Yeah, you're ahead of me. Plus 9 minus 9, right? You guys agree with that? But if I just look right next door, there it is. I just factored that one, didn't I? So let's factor the x squared minus 9 again, because we know what it is. We just did it, right? You cannot factor the x squared plus 9. I'm going to show you why, okay? This will not factor, but x squared plus 9. Yeah, remember how you can't factor that?
Because then it would make a middle term.
It would. You are paying attention. It does make a middle term, right? So x plus 3, x minus 3. There you go. Nice job, Becca. You need to play this back so your mom and dad can...
My mother and dad love me on it.
Of course they do. All right. So are you ready to turn the page?
Yes.
All right. Now, if you get 4 terms, there's a type of factoring called grouping. And I don't know if you learned this in algebra or not, but we're going to learn it again, okay? So if you get 4 terms, you're going to pair them up. Because if I look at all 4 of these, they don't have anything in common, right? But if I put these first 2 together and these second 2 together, I can individually factor these 2, and I can individually factor these 2. So I'm going to take a look at the first 2, and I'm going to common factor. Common factor, okay? So I look at the first pair, and I ask myself, what do they have in common? Garrett, what do these 2 have in common?
They both have an x.
In fact, they both have x squared in common, right? You're right, they both have an x. In fact, they have even more than that. They have an x squared in common, right? So if I pull out, common factor, if I pull out the x squared out of both, if I take an x squared out of an x cubed, I'd just be left with an x. And if I take the x squared out of the negative 2x, I'd be just left with a negative 2, right? And of course, that confuses you. You can just go backwards. That times that, x cubed, that times that, negative 2x. Okay. Now, the next two, what do they have in common? Let's take out a negative 9. You're right. 9 is correct. Let's take out a negative 9, and I think you're going to see why I want to take out the negative 9. So if I take out a negative 9, I'd be left with just an x. And if I take a negative 9 out of an 18, I'll be left with a negative 2. Now, if that bothers you a little bit, okay, go backwards. Negative 9x and a positive 18. Agree? Positive 18, because you pulled out its negative. Okay. Now, I'm not done. What do these two groups have in common?
X minus 2.
Yeah, so they have a parentheses x minus 2. Now, when I common factor out the x minus 2, I take it out of both, right? I pull it out of both, and I'd be left with an x squared minus 9. And I only write it down once. Real quick, a little sidebar stuff, because this bothers people. Let me go ahead and do a little. If I've got AB plus AC, and you common factor out the A, right? Right? I only wrote the A once, but it represents both, doesn't it? Right? I pulled out the A once, but it represents both. Same thing here. I pulled out the x minus 2. This 1x minus 2 represents both of them when I go ahead and multiply through. Hey, but I'm not done with this, because I've seen this before, right? I can do this one more time, right?
Yeah.
Do this one more time. So my answer would be an x minus 2, x plus 3, x minus 3. Okay, that's fully factored, all right? That's fully factored. All right, example 8. Okay, if I look at example 8, I'm going to pair them up. Same thing. Pair them up, put these two together, right? So if I pair them up and find out what they have in common, what do these two have in common?
X squared.
X squared, right? So if I pull out the x squared out of the first two, I'm left with, what am I left with?
X.
How about a 2x plus 1? You okay with 2x plus 1?
Could you just put 2x?
You have to have a plate. You have to have the one here, Will, because if you go and distribute back through, if you don't have the one, you can't get the original x squared term. Really good question, though. Does that make sense why you have to have the one here?
Yeah.
Because if you go back, you would not be able to recreate your x squared term, right? Okay, what do these two have in common?
4.
Yeah, plus 4. If I take out the 4, what do I have left? 2x plus 1. All right, let's finish it up. What do they have in common? 2x plus 1. What's left over? And I cannot factor that again. So one of the things I do to help kids is I cross it out when I take it out. That way you're not worried about having two of them, right? Okay, now number 9. Let's write some numbers down. I want you to write these numbers down. 1 cubed is 1. This will help you. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. And I think 6 cubed is 216. Better figure that out. Hold on. 6 cubed is 216. Yep. 7 cubed, that might be all the further we have to go.
338.
343. You're close. 343. Okay, these are perfect. These numbers are perfect cubes. Okay? These numbers are perfect cubes, all right? So what I want to do is rewrite it so it's a cubed plus a cubed. So when I take a look at example 2, I'm going to rewrite example 2 as x cubed plus 2 cubed, right? So if I'm going to use my formula, it's right there, right? I'm going to highlight it. If I'm going to use my formula, then I'm going to let my a be my x, right? I'll let my b be my 2, right? So I've got my x cubed plus my 2 cubed, and I'll just plug it into the formula. That's all I'm going to do. I'm going to put my x plus 2, x squared minus a 2x plus a 2 squared. All I'm going to do is this. So the answer is a x plus 2. So I'm putting my x here, my 2 there, parentheses, x squared minus 2x plus 2 squared, which is 4. It's factored. You don't have to, but if you were to multiply this all out, you'd get x cubed plus 8. If you did with that times that, that times that, that times that, you would get x cubed plus 8. That'd be your answer. All right, example 10. Same thing, except for it's got a minus. So let me rewrite this as a 2x cubed minus a 3 cubed, okay? You with that? 2x cubed minus 3 cubed, because that's my 27. So now here's what I know. In this case, my a is 2x, and my b is 3. And then all we have to do is just plug it into our formula. So here's our formula. Put it into our formula right here. So I'm going to go, all right, I'm going to go parentheses 2x minus 3, okay? Parentheses. I'm going to square the 2x, which is going to give me a 4x squared. I'm going to square the 2x, which gives me a 4x squared, plus 6x. Do you see the 6x? I'm going to multiply those, 6x, plus 3 squared, which is 9. That's it. It's factored.
How do the 4s?
Great question. In fact, I'll do this. If this is 2x, then a squared is 2x times 2x, which is a 4x squared. Okay? If this is 2x, if I square it, I get 2x times 2x, which is a 4x squared. Okay? All right. 11, last but not least. So we got to help. 11 needs a little bit of help. Okay? 11's not ready to go yet. So I'm going to try and common factor first. Let's common factor first, see what happens. So they have a common multiple of 5, and they have a common x, okay? Right? So if I common factor out of 5x, what's left in the first term?
X to the 3.
Good, we're getting a cube, right? Plus, if I take out, I get an 8, right? And we just did this one. We did this exact same problem right above it, right? We did this exact problem right up there, right? So it really is like a 5x times a x cubed plus a 2 cubed, right? And we're just going to use our formula up here. Since we already did it, let's just write this answer right down there, right? We just did it. So we'll go parentheses, we'll go x plus 2x squared minus 2x plus 4. And that's completely factored. Okay, now this isn't hard. You can do this on Tuesday's test. We're going to have this on the board, right? Or on a note card, but I'll just leave it up there,
Where?
and we should be good.
On